Kevin Colt back yet at Supermicro. So what I've done here is I've logged into both our KVM hypervisor and NFS storage server to kind of navigate around and give you some idea what some of the configuration was done on the NFS client, being our hypervisor, and our NFS storage server. We'll show you how to set up the bonded NICs. We'll take a look at the configuration scripts for each on both the hypervisor and also the storage server, and how you set up the bond itself, right? So let's do a little bit of troubleshooting here and find out if things are set up correctly. As in the previous video, we established the LACP channel group for our presentation of VLAN 720, which is going to basically forward our storage traffic across the TCP/IP link through layer 2 switching of both the client and also the server. So now we need to just make sure that that traffic's going to flow correctly and it's been set up correctly. So the first thing we want to do here when we're basically troubleshooting is take a look at, do we have an IP address on our interface or on our bond? So what we do here is we can create the IP address show and grep it to bond. And what it does is it shows you specifically how things are set up. So let me just scroll over here a bit here to give you a better idea of, looks like it's not able to, try to get many windows up here to show you differences between both. But you can see here that we have the IP address set for 192.168.5.2 / a 24-bit subnet on the NFS storage server itself. And the other key point here is that the bond state, right? Bond 0, the state is in an up position. So far so good. It's looking pretty good. We have member 0 and member 1 as members of that particular bond itself, right? So let's clear that out and let's go over to the hypervisor. Do we see exactly the same thing? I would hope we see the same thing because it's the same setup over there. So let's grep it to bond. And yes, we see basically 0 as a precipitant and F1 is a member to a precipitant of bond basically 0. And we see here an IP address of 192.168.5.1. So far the bond looks good, the bond is up. But we want to kind of say, is it really up, right? Is it operationally sending LACP PDUs between the bond and what we call the storage switch? So PDU stands for Protocol Data Unit. So there's sort of this keep alive that takes place between the bond and also the switch. So it's using what we call an IEEE 8023AD standard that everybody agrees to, both the switching vendors and then also specifically the system manufacturers or the operating system deployments, whether it be VMware, whether it be Linux, whether it be Microsoft, so on and so forth, whether it be Ubuntu, CentOS, RHEL, all of the various different implementations definitely go ahead and follow the standard. So if we clear out that side, and I'm going to show you a little trick here because sometimes typing can be a nuisance, right? And I'm becoming lazy in my older age here, so I like to see if I can minimize the number of keystrokes. And when I do the history grep bond, it shows me all the various different commands that I have issued here when setting up my bond. Like, for example, mod pro bonding has to be created, or the command on initial setup needs to be executed. And then also the other one is my cat proc net bonding, where I can actually see if the LACP is set up correctly. So if I hit the bang, which is the exclamation mark in 5.5, and hit return, it immediately executes that command. So I minimize the amount of keystrokes of having to do the cat command. I've done 3 keystrokes and I've been able to achieve the same goal as having to type out cat, blah, 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 Etsy, proc, so on and so forth, right? So let's scroll up and take a look at what we see here to see what we would expect to see when the bond or channel bond has been created. So the first thing it does is we want to look at, it is an IEEE 8023 AD bond. It's dynamic link aggregation. It's using LACP rate of fast itself. And we see members. The first member is F0, and the second member is F1. And then we also have specifics of key information, priority, and various other things associated with the LACP bond itself. And so the hardware address basically is the one that provides the permanent hardware address of the actual NIC, and there are other things that are set up associated with the system MAC itself too as well. So this is the bond itself, and it is operational. So if you recall in the previous video, we saw the channel group where we had selected members or ports to establish that channel group over on the switch, and we presented VLAN 720 for those packets to flow across that particular link. So that communication channel is now open for us to be able to communicate and get those mounted drives on the NFS server itself. So we'll clear this out. And let's look at the other side. We would expect to see the same results on the other side. So let's do the history grep bond. And what we want to do is we want to execute 102, which is this one here. So we're going to issue a bang 102 command. And lo and behold, we see the bond information associated with our hypervisor. Same kind of stuff is present. It's using dynamic link aggregation, and it is IEEE 802.3 AD. It's using an LACP rate of fast, and then when we scroll down, the members are 0 and also 1. And then we have our LACP-DU information and key information. So far, so good. We actually see an LACP port channel established here. So now we're going to move up the OSI reference stack, right? So we're looking at the physical layer, right, of how the electrical connections are there. So now we need to look at the transport layer, TCP/IP, and see if we basically have reachability. Right? If TCP/IP transport is reachable, then we can look up the next layer, which is the application layer, where the client and the server and the ports that are open are available, right? So when you're creating the NFS storage server and client, there are many examples out there that both Red Hat provides and some folks in the Linux community provide, and set up of basically a client and NFS storage server type of environment. Be careful, because sometimes firewall can rear its ugly head and prevent you from RPC, or the port that's open for these two client and servers to communicate. So RPC is remote procedural call. That is basically the the actual program, or what we call the application that allows these devices to communicate using an open port itself. So we've looked at the physical layer, we've looked at the idea of the two being connected, and LACP is working and load balancing correctly across the links. So let's step back a minute and say, well, gee, Kevin, how do I set this up? How do I set up these bonds? How do I set up the interfaces so they can participate and be members of a bond? How does all that work, right? Well, there's an area within Linux, especially CentOS, where we have a location on etc sysconfig and what we call network scripts. And so if I spell it right here, and if you hit the tab key, you notice that it was able to fill the rest of the line in. Another very useful technique so that you don't have to type out all the commands, right? And if we go ahead and hit enter, we're into the network scripts directory. We type an ls command, and we see specifically some of the scripts that I have created here to allow for that bond to exist, right? That LACP bond that we're looking at. And should be a surprise here. It's interface 24S0F0 and F1. So both of these are members of the bond 0. So why don't we take a look at the script and see what it says in there, right? So let's click there, cut and paste it, and we'll look at the script. So now we're looking at the catalog or the contents of the script using a cat command. If you needed to go and create these scripts, you could use Nano or VI editor to do so. So depending on your comfort level of Linux, I personally like VI, but there are other folks that in the Linux community like Nano. I happen to be an old school Linux guy. That VI was basically there from its inception under Linux. So, you know, you can't teach a dog old tricks, right? Because once you're locked into a method of doing things, it's very hard to break those habits, right? But in any event, so when you look at the EMP24S0F0 interface, we have detailed information there. We have the type of device it is. It's an Ethernet device. The protocol is set to none. So there are two ways to define a static address. You can basically set it up as essentially a protocol as none, or basically static. But because you're bonding it, the IP address exists on the bonded interface. If you were setting up just one particular interface, you could set this to DHCP or basically static, right? And then that would depend on whether you had a static IP address versus a DHCP address that was scoped from a DHCP server. So when you're setting up an individual interface, you would set that up, and the bond is where you actually configure the IP address. And then the idea here is master equals bond 0, and then you also have the slave equals yes. So if you wanted to look at the other interface, it's identically the same, no changes there, but the device name is different, right? And you notice that the actual script name is basically different too. But the information and contents in there are identically the same. So let's clear that out, get rid of that gobbledygook, and then type an ls command again. And now let's look at the bond 0. Let's see how that's set up, right? So if we go and click on bond 0, paste it in, and lo and behold, we have bond 0 and bond 0. Incidentally, I'm actually connecting in through PuTTY. There are many different terminal emulators you can use. Again, I've been using PuTTY for a number of years. You can't teach a dog old tricks, right, or new tricks, right? So at this point, I'm actually looking at the contents through the catalog command, and we've provided an IP address here, and the prefix is set to 24, which is a 24 subnet. Do you have to use the prefix attribute or parameter within the configuration script? Absolutely not. You could use a netmask command, or netmask equals 255.255.255.0, right? Would also be legal, right, in configuring your script. And then this is the big one here. This is where we actually set up what we call the bonding options. So mode 4 is LACP. If you were to go out and do a search or look at the Red Hat Linux manual or CentOS, there's information. We have many examples out there in the community to show you the different mode settings that you basically set. You can set mode 1, mode 2. They mean different things. So I'm not going to get into that detail of what they all mean, because it's not really pertinent to what we're basically doing here in the lab. We want to establish a dynamic LACP connection, so that's why we've set it to mode 4. So that's on the NFS storage server, right? So we saw the 5.2. So how do we see the 5.2 as part of the bond again? We can basically issue an IP adder show and grep it to bond again. We'd say bond 0, right? And lo and behold, we see now that the 5.2 address shows up as part of the bond. So it's looking pretty good right now. It's looking like, things are kind of set up. Let's go and look on the other side of the house, basically the KVM hypervisor. Let's go to our etc sysconfig network scripts location there, and let's see what things are set up over there. So ls again, and these ones here, we'll get into detail for basically bridge 0. These ones here we'll get into a little bit later, what those scripts are, and then these ones right here a little bit later. So again, we've had the 2 physical connections to our switch that we've defined on our Sonic switch that were connected physically. So these are the interfaces that have been enumerated. So let's look at each one of those scripts. Are they different? No, they're exactly the same, right? They may be different nomenclatures as far as the actual enumeration. That when Linux basically builds its enumeration tree for PCIe, it may build different device names associated with the loading of the operating system, because different particular NICs have different nomenclatures that they basically get built, right? But because of our case, we're using specifically a NIC, which is one of our Supermicro NICs. We call an AOC an add-on card. They come up with these nomenclatures for the enumeration. So let's go ahead here and click on the cat command. We execute the command, and at that point, we basically have a 0F0. We have an Ethernet type device, and then protocol is none, and bond 0 and slave. So same kind of configuration that we did over here on the hypervisor. No changes there. So now let's look at 1. Same information, the device just changes, and we have the bond 0. So again, same configurations that take place. One of best practice you should do is when you're doing your naming convention associated with your bond or doing various configurations, try to document it, right? Try to provide people that follow you, right? Perhaps maybe you're an administrator and you're going out on leave, right? your colleagues, give them a break, right? Help document things so it makes it easier for them, right? Because that's not really a great thing to have your colleagues have to chase around and find appropriate information. It just takes them a lot of time, and eventually, if it becomes a down situation, you want to try to get these systems up as quickly as possible in your infrastructure. So let's clear the gobbledygook out again and type an ls command, and let's look at the bond, right? So the bond will be the same kind of thing there that we'll see for bond 0. And you see here the mode setting that we've set. So we saw that mode setting has configured on the NFS storage server here. And then we have a 5.1 type of IP address. So if we wanted to see the IP address to see the bond has been established, we can certainly issue the command IP adder show and then grep it to bond 0, and lo and behold, we have the IP address and also the bond state as being in an up state. So far we've got the physical layer intact, right? So let's move up to the next layer, right, which is really the transport layer. Do we really have IP reachability? Because at this point, if you can't ping the device, the school of thought is it's maybe 95% of the time. It could be a routing issue, but most of the time it's a tagging issue, right? So let's see if we can ping. If we can't ping, maybe we didn't configure the switch correctly. We didn't configure our bond correctly. We didn't configure also the interface correctly. So let's go in and ping. Again, so I don't get lost here, I want to show, get an idea what IP address this is, so I don't get wrapped up here in things. So let's stay at bond 0. Okay, so we're 5.1. Okay, so we're going to do a ping to 5.2. So we'll do a ping 192.168.5.2, and we can ping, right? So that's good. So now we've physically established communication through the TCP/IP transport that we're able to communicate between the client to the server. So let's go the other way. We would expect to see reachability over there too. So we can issue a command ping 192.168.5.1. And we can also ping in the other direction. So usually you want to try to see if you can ping in both directions just to make sure that you have what we call bidirectional reachability, right? So at this point, we've established now TCP/IP is communicating, layer 2 physical connectivity is working. We have the LACP port bond working, the LACP port channel is working over on the switch. So things are looking pretty good. They're looking up for us, right? So the next thing is there are plenty of examples, like I mentioned, to configure the NFS storage server. But how do you actually go ahead and share the disk, right? Well, first of all, you need to make sure that the disk is mounted local to that server. So how do we do that? Well, if we do an ls block command, let's see what we have out there. We certainly have an NVMe drive, and look, we've got a mounted VM host repo directory, right? A file. We went in and did the GPT GUID partition setup. We made file system, and we prepped this file system for it to be essentially presented across the network to our clients. So if we issue a df command, we see here specifically now that the NVMe drive has been mounted, and looks like it's we've got some contents in there, and it's called VM host repo. So what we can do here is if we CD back here and go back to let's go back to root. Let's see where I am, PD. Yes, I'm in root. So now if I go ahead and hit the VM hosts repo and hit return and do an ls command, wow, we have some QCOW images already present in here. So these QCOW images are the images where we instantiated those VMs and set up the storage pool and the various hypervisor to be able to look at this VM host file, right? So anytime we instantiate a hypervisor VM, the QCOW image, which is where the contents of everything is stored, is here in this directory itself. So, so now we've established that the volume is locally presentable to that storage server. Now we need to determine, does the client see that storage volume, right? So that we can write our instantiated VMs in and store them there in that location. So we'll clear this one out because it's a little busy, and we'll come back over to the hypervisor and we'll issue an ls block command again. We'll find out here that at this point we have the mount OS distro, but we don't have specifically the VM host file that's located, right? It's not there. So what we can do here is let's first, before we do that, we'll do a mount -a and then do a df command, and now we have the VM host command is showing up, right? So we've now executed the mount command. That mount command now is available to our client, right? So if we were to CD into that location itself, so we have what we call a symbolic link pointing to var. If we just kind of just go to that location, mount VM hosts, and have an ls command, we see the QCOW images, right? So when we went over to the storage server, it was locally significant, right? Because that's where the volume physically resided in that storage server. And now on the client side, we've issued that mount request itself. And now we see basically that drive or that volume that's part of what we call the KVM hypervisor to store QCOW images. So where does, though, that information reside? How do we set it up over on the storage storage server itself? If we cat out what we call the etc exports directory, we see here that the VM host is what we're actually serving out to our client, and we say any particular network or any particular system that's part of the 5.0 subnet with a 24-bit subnet, so machines from 1 to 254 are able to connect to this network, right? So we've set up this environment. If you had additional NFS mounts and locations you wanted to do, it would be present in this file. So could we take the OS distros and create a directory over there and serve it out to the client? Absolutely, right? But in our case, we've decided to use the NVMe drive that's local to this hypervisor to store our distros. And that information is stored in, let me clear this out again. So we can come here, type .df, they're located in this file right now. So we have our distros mounted. So we have an NVMe drive, and these distros are located in this particular hypervisor, local and physically in this NVMe environment. So again, the NFS relationship client to server is basically there. I want to show you one other thing here at this point is to look at the etc FS tab. So when you reboot your system, we want to make sure that that information is preserved within a file. So on boot, all of these particular mount points get mounted. So we can do a cat command and do an etc FS tab is the location of where we have this information. And if you can see here, I'm just going to hopefully make this larger so there's no word wrap here. It's kind of a little bit of word wrap, so it's hard to determine this. But you can see here, this is our mount point for the distro, and then this is our mount point for NFS for our VM host repo. So our storage presentation is ready to go. So that completes our storage presentation with this video. We'll see you next time. Thanks for joining. In the next video, we'll focus on presentations of the virtual machine traffic for compute traffic. So we'll define VLANs 100, 200, and 300 on our wrist to switch, showing you the third-party support we have with SuperCloud Composer. We'll show you that information in the next video. And then following videos will basically give you an indication of how you set up your hypervisor, how you instantiate VMs, how you define trunking, 802.1q trunking for those specific VMs to connect to the network through separate different VLANs and tag traffic, and how bridges are configured on the hypervisor so you make your connection between vPorts and vNICs. Thanks for joining. We'll see you next time.